did I almost forget we have a live stream today? I did. Luckily, our guest today didn't. So it's going to be great to talk about the Zephyr shell today. I think, did we? Yeah, we might have had a tech talk in the past about using basically the Zephyr shell over Bluetooth. So you can definitely check that out on our YouTube channel, which, by the way, if you're not subscribed to, now would be a good time. Now would also be a good time as we are sort of gathering people both on LinkedIn, YouTube. As always, take a few moments to say hi in the chat. Where are you joining us from? Who are you? And usually, as many of you probably know, the chat is usually quite active during those live streams. So please make sure to send your questions and or to interact among each other. And talk about. I mean, of course, today's topic, but you can also discuss, like, if you want to see something in a future tech talk, you can also definitely mention that in the comments. So, I'm Benjamin, by the way, your host, joining from France. So, waiting to see about a few of you guys. Where are you joining us from? Please drop that in the comments. And let's bring in our guest, who's joining us, I think, from North Carolina, is that correct?
That's right.
Remember that right?
North Carolina.
Yes.
Yep. Hey, welcome.
Okay, so Chris,
thanks
welcome.
for having me. I'm so used to hosting these things, Ben. Thank you for having me. I was like, welcome to my stream, Ben.
So should I introduce myself?
Yeah.
Do we go into some kind of end loop?
Here's what I'd love to. I would love to highlight how much good you've done for documentation. Like literally, when I was doing this project we'll be talking about, like I was just like, oh, thank goodness Ben is doing the tough work on the back end, as well as all the developers. Like so much stuff that I built on top of. So
yeah, well, actually, the reason I was late and sort of distracted, I guess, is that I was fighting with CSS in our Doxygen documentation. Recently deployed a new upgrade, and apparently, I usually use dark theme, and this time around, apparently I wasn't, so I didn't test dark theme, and it's kind of like broken. So should get that fixed soon. But yeah, thanks. So Augustin, I think name doesn't look familiar. So welcome, new faces, always nice. Philip Dillon, certainly familiar with that name. Augustin, you're welcome. George, I think that's a new name as well. So cool. So yeah, Chris, I mean, many folks on the stream probably heard about you, maybe listen to your podcast or see what you're doing at Golioth, because that's your current gig, right? So what are you doing at Golioth?
Yeah, so I'm the head of developer relations and hardware at Golioth. And mostly that means I get to build lots of demos and try out. I get to be kind of the guinea pig for a lot of the things that Golioth is building. Golioth is a IoT SaaS platform that basically makes it easy to connect devices, and often Zephyr devices, in my experience, to the cloud for things like over-the-air updates, data streaming, command and control. And now we're even moving to things like Bluetooth, which is really exciting too, because now Zephyr is so great at Bluetooth stuff. I've been getting to learn a lot of things in the kind of the low, even lower power realm, and then the Bluetooth devices go back through these standardized gateways up to the cloud. The whole idea is, if you need just to connect stuff to the cloud, don't keep building the same stuff yourself. We have very open documentation on all our stuff, open infrastructure. It's often just a single library include for getting stuff working, like OTA. So
nice. Okay. And I guess an interesting sort of angle is that you're not necessarily, at least last time as far as I remember, you're not necessarily a software engineer, right? You're more like an electronic engineer by background. So I'm sure we will get to talk about that at some point. But
you may hear me refer to myself as a hardware dummy, because I like hardware and I am a dummy when it comes to all other things, including firmware, including cloud. And so all the things that you see me doing today are enabled by, again, like shoulders of giants, like all the people I work with, all the Zephyr developers, all of the vendors that participate in Zephyr, like all of this stuff. None of this would be possible without everybody else. So
yeah, we were just before going live, we were discussing about like how, you guys are putting lots of content out there, lots of demos, and I guess if people like you, and obviously you're very smart, but if you're not a software engineer and still able to sort of like assemble all those pieces and come up with some interesting and functional stuff, then I guess it says something about the fact that it's probably the experience has improved over time, and maybe things like the sort of like full stack engineer for IoT is becoming more and more of a reality. Like sort of by definition, you have to know a bit about everything. Like
Yeah, I think who's got time to learn everything and do everything anymore, right? And also, one thing we talk about is just like we're going to talk a little bit about security today too. Like it's almost irresponsible to build from the, you should obviously audit whatever you're using, but like if you're building from the ground up, you're probably just going to miss the same thing that everybody else misses. So by building on top of other things that are well vetted, well tested, then you can accelerate your timelines, but then you're just a little bit safer. You're a little bit, you can do more. And one thing I talk about is, take everything else away, like the, wanting to learn stuff, anything else like that. Most of the time, what I'm trying to do is like impress my boss and like, get a raise or like, like I know that sounds like kind of capitalistic or whatever, but like most of the time, like the things that I'm trying to do is like just get to that next milestone and like make something work. And that's
and the fun part might be to actually reinvent the wheel and to like solve a problem that's been solved 1,000 times already. And sure, you will learn a lot. But the smart thing to do is usually to do everything but that, and to be like, hey, is there anything that already does? I'm sure there is something that already does what, like 80%, if not more, of the problem I'm trying to solve. And let's find that, whether it's like some kind of library in Zephyr, some kind of like third-party stack like Golioth, and then let's just focus on the rest.
Right.
Yeah, it might be boring to some extent, but I also do enjoy that, like the ability to just like build a sort of a mashup of stuff that already exists. Spend some time doing the due diligence and making sure you're actually picking up bricks that are solid enough. But yeah.
Yeah, I feel like the prototyping stage is a lot different than, you can, these days you're going to hear a lot of people, they're like, oh, there's some LLM stuff, coded front end stuff in here, right? That doesn't mean it's ready for production. I would never, ever, put this out into the world as like a product, but it's a good starting point. This is a hack project. If that wasn't, I think that was talked about in the intro, but this was a hack project built on top of existing infrastructure. But like the pieces there are some hacky pieces in there. And if it's going to be like a thing that like was a full-fledged production level thing, you should be vetting it with your security team, with your your engineers. They should be putting it through its full paces, that sort of thing. And so I think the duality is the prototyping stage, getting up and going fast, and getting something working to prove out your business use case, your point, whatever it is, and then your full-time, like, I'm going to push this out to thousands, tens of thousands of users. That's a very different thing.
Yeah, so you and I think most of our, I feel like most of our conversations on Discord, they revolve around the Zephyr shell, because I think we both like it very much, right? And that's kind of the, but yeah, I mean, it's pretty awesome. There's like virtually every subsystem in Zephyr has its own shell module and the ability to just interact with the subsystem script almost to some extent, whether it is like sensors and interacting with all the sensors you have enabled on your system, getting data from them, reconfiguring them for those that expose some like attributes and whatnot. Same for the network connectivity. I'm planning and preparing the demo video for Zephyr 4.2. There's like a lot when you deal with Wi-Fi, for example. The shell commands to like set up credentials that you save in Flash, like you save your SSID and password in Flash, and so that you can easily auto reconnect whenever that Wi-Fi SSID is in proximity. Like, yeah, it's pretty awesome, and I guess it's even more awesome when you do it remotely, because like the ability to just like get and log SSH virtually right into the system and interact with it is pretty cool. So that's what you've been sort of building recently, right? And there's many ways to do that. I guess I should mention many ways that are already at least like at the many ways in Zephyr to enable that. Maybe not necessarily securely or like more in like a production ready way. But the Zephyr shell can be accessed over different media, right? It can be exposed over a regular like serial port, which probably doesn't give you remote access or at least internet access, but it can also be exposed over MQTT, over telnet, things like that. But then I guess what you did is sort of like add another layer so that you can actually connect to a device that's effectively like a running IoT device already securely provisioned to a cloud platform, and you want to get like shell. But I should let you talk.
Well, no, it's fine. I think actually a lot of the ones I was really surprised about the various backends that were already enabled. So like I think SMP's
and there's
on
more
there as
than
well.
what
Yeah,
RPC,
there was a bunch. I'm trying to pull up the
totally.
page here too. I lost my mouse, of course, because why wouldn't I have done that during a show?
Maybe you can look at the that's one way to look at it. I was going to look at the kconfigs, but that's another one. Yeah, Bluetooth. And Louis just said
yeah, I just saw Louis in the channel.
Yeah.
Good timing,
USB,
man. Good
of
timing.
course, USB.
Yeah, and SMP is great for doing like loading up new images over using that transport layer, that sort of thing. A lot of these though are very point to point, like even RP message. I think I didn't know about that one. That one's pretty interesting. It's like an interprocessor communication, usually like a high powered Linux device talking down to a small Zephyr device. I wasn't sure if that's maybe like the Google folks doing that with the
don't remember, but yeah, that could be. I mean, the use case would be something like I don't know, like you have an external modem potentially, and like you want to have I quite frankly I don't know how
it looked like it was like almost like a shared memory bus kind of thing over different transport. But like I was also thinking about like BeagleBone style chips that are like a style core that are talking down to a small real-time processor running Zephyr, that sort of thing. So that was a first experience for me. SMP we've used, but all of these are kind of point to point. MQTT obviously is not that, but even so, the thing you don't have is the ability to kind of dial into them, right? So like Telnet, maybe you can have dial in, but you don't want to have these publicly exposed. You don't want to just say like, hey, I'm hanging out at a public IP address from this Wi-Fi device, and whenever I want to, I'm gonna
and even worse if it's cellular, because like it's really behind like tons of firewalls / VPNs / APNs /
exactly.
Yeah,
it's a mess. And this is going to be a cellular thing we show today. But one of the things that kind of the Golioth SDK, the way it works is a cellular device. It wakes up, it registers, it gets a cellular connection using SIM card through a modem like the NRF9160. It talks through a public gateway to the coapp.goliath.io, I think is the endpoint. But basically, it reaches out and it connects to Golioth, and that's kind of the device management thing. So now I have a bunch of devices that are configured to check in at various intervals that are all configurable. And so they have these, they can punch through the NAT, firewall, maybe not the firewall, but basically they can punch through and get to Golioth. And that's kind of the big thing there. We don't actually have to know the public IP address of a cellular device, because it's the device itself that's reaching out, checking in for messages, settings, all of the things that we offer. And so that's kind of one of the things that I wanted to put in here is the ability to build on top of that infrastructure. Because now I have not just a point-to-point device where one device gets one shell connection. It's literally one device, hundreds, thousands of devices that are checking back in and saying, hey, do I have a command waiting for me? In this case, it's called remote shell. And this is very similar to things like, of course, I can't think of it now. All of these services that they kind of punch through firewalls as well, right? So they kind of do reverse. Boy, I should have had these up.
I'm using the same. I know what you mean. And basically the way it works is that you ping the server, you initiate the outbound connection, and then the route is then open to do it the other way. What's
exactly?
Yeah,
Tailscale is one of them. That's kind of like a truer like networking layer thing. The thing starts with an R. I don't know what it is. But anyways,
this is your opportunity, people in the chat.
They know what we're talking about. They know what we're talking about. So anyways, we built on top of what's called a remote procedure call. So this is a Golioth thing. So I'm just going to go into the Golioth shell now and we'll go to the tab for remote procedure call. And this is a little too big. We're going to see, this is kind of like in between there. All right, so this is a very zoomed in view, just so Ben very smartly said, make sure we can all see it. But I created RPC here. And so this is just sending down the thing.
ngrok, sorry.
That's it.
There you go.
I said R, didn't I? Yeah, ngrok, thank you. That's exactly what I was thinking of.
Oh, Jonathan.
Yeah.
Between two. Yeah.
Great. And so this is calling a thing on the Goliath cloud. So I'm going to be doing this through the REST API, where I'm going to be calling into this, call into the remote procedure call endpoint on the REST API. And then I'm going to give it, the command is just remote shell. And then the parameter is really what the command is that I normally send into the terminal, right? And we'll show this demo in a second, because that's going to be a little bit better here. But ultimately, this is built on top of remote procedure calls, which basically then say the device, which is out in the world, is listening to the cloud. It has observation set up, CoAP observation set up. And then when there's a new RPC available, it pings it out, and then the device says, okay, I can go and grab what this latest command is, pull that down, and then run it. And so basically now what I needed to do is I had to then say, okay, well, I'm getting a command in. I need to be able to shove that command into the shell, but do it from the runtime. I'm not going to be doing that from any kind of active UART serial terminal type of thing. It's going to be doing that from the runtime, and I need to then also be able to return what's coming back from that, again, not to the serial, but to something else. In this case, it's going to be to a buffer, which then gets pushed back into the remote procedure call. Which brings me to the first limitation of this, just Hackday project, is that we are limited currently by the size of the CoAP packet size, basically, which is like, I think, 1024. So what you'll see is I had a lot of struggles figuring this out, with just like some things would time out, and it was because the response was too big. So when you type something like help, and so let's actually go and do that. So this is the front end that I built. I'll talk about this a little bit later, but if I just type in help, so what this is doing, it's going and it's talking to the Goliath REST API. It's then getting the response from Elixir One. That's the device that we're connected to. You can see I have different devices that I query for. This is the device that's, actually I have this device right here. Oh, that's live. And so that's one that it's talking to there. And so all I did is type in help, really useful command. And so you see at a certain point, though, it actually gets cut off, right? That terminal screen size, or assumes D what? And that's just something I've just learned to work around here. And in fact, I created a custom shell command, this was a great forcing function for me to start building my own custom shell commands. And now I just write list, and now it just kind of strips out all that other information, and that works great. So now I can see all of the things without the helper text there. So this is all the things that I have compiled in to this device currently. So what this is doing is this is a public JavaScript app, but you need to put in a Goliath API key. That's here. You won't see that. You need to put in your project name, and then that's going to be talking to the Goliath REST API. Then I could call it. Then on the back end, or sorry, on the underneath the hood here, it's calling that remote shell function. It's pushing in whatever I type in here. So if I type in some kind of garbage here, like hi, right? It's just going to say, I don't know what this is. Yeah, hi command not found. And then it's calling through the REST API, calling down to the device. The device is pushing that into this remote shell function, basically, that's running in Zephyr. It's getting the return back from the shell under the hood, and then it's pushing that back up the chain up through RPCs. So like pretty long distance. Yep. And including cellular. So that's why you see the cellular is actually the slowest part here, but that's why the round trip is 4.72 seconds. But if it's anywhere in the world, that's pretty cool.
Nice. And so just on the 1024 limitation, this is sort of a Goliath RPC limitation, because technically, I guess one could use CoAP blocks to have larger payloads, right. Correct?
That's exactly right. Yeah. So this is just kind of not implemented yet, because why would we need this so far? But yeah.
Typically, you want, if you can keep things concise, that can only be better. And 1024 is usually, I guess, plenty for
Yeah.
regular RPC. You want to
Right.
query your temperature or whatever. Yeah,
Exactly.
okay.
And we do have, so just so it's clear, we do have blockwise download and blockwise upload implemented in CoApp. So that's how we push down firmware images. That's
Yeah,
how we push up things like photos and things like it for AI processing, stuff like that. So all of that is there. It's just that that is not then pulled into
for
RPC
RPC. Yeah.
because most people are not doing these crazy hack projects.
Yeah, that's fair. Okay, cool. So yeah, do you want to show like some of the code maybe of how this looks
Sure.
like how the backend looks like?
Sure.
Um,
Sure.
yeah,
Now, this is the part where I say I am a hardware engineer and
sure.
please
I would.
excuse
Yeah,
all code that you see here. Uh, yes. So I do have a shell busy symbol here because the thought was if I had multiple commands coming in, stuff like that, I just set up a semaphore for that sort of thing. But here's the backend init and some other functions that are just kind of placeholders there. And then this is the actual backend write. So this is where it's pushing stuff in. This is the setup for when you're setting up a custom shell transport. And let's see. This is a function just to clear out one of the buffers for, so when it's done, this is just some cleanup code just for clearing out the buffers at the end of a transmission. This is the command complete. So this is basically just saying clear out the buffers, give the semaphore back. This is the definition. This is where I'm defining the Golioth remote shell here.
right.
And so this is passing in the buffer, but this is basically the macro that sets it all up.
Yep.
UDP, CoApp is UDP.
Yeah, I guess otherwise you would likely not have the limitation, or
Yeah.
maybe
Yeah, Daniel Mangum, who's there, is our CTO as well. So he'll probably be able to answer questions better than I am.
You both.
Okay, so and then this is ultimately the command that when I get in a text command from an RPC, this is ultimately what's making it do that sort of thing.
Okay, so
that's
the callback that's hooked to the Golioth SDK, and it's like.
That's a little further down because this is actually called in the RPC. So when you get when you boot up, basically you're going to register an RPC, and that's going to set up things like CoApp observations. It's going to set up the what command you're looking for, that sort of thing. Because then we also have additional logic for. So if I go and let's see. So if I go back here real quick and I just type in a garbage term here, what you should get is actually something like this, like error no response. That's going to be, so RPC not found. That's something that like, it's just, we have not registered that RPC. This is the only one that's actually registered on this device. Actually, there might be other ones registered on this device. Let's see. Get
like built in.
This is, so this is another one that, I guess I didn't implement this one. There's a reboot. There's like common ones that we put into a lot of our reference designs that are like that. Get network info looks up the cell information and things like that. But we can do that from the shell now as well. Same with rebooting. So a lot of the stuff that you're seeing here is kind of a construct that I'm used to, like an SSH type construct that it's all been possible through RPC, but like you didn't need it because you're going to be calling it, for a fleet of devices, it's actually pretty inefficient to have someone sitting at a console and typing this in. What you really want to do is if you have 10 devices in Tennessee that are not working, you can call 10 devices to go reboot themselves, right? That sort of thing. And you do that by scripting it. You wouldn't do it by, device one, reboot, device two, reboot, right? So again, that's why this is a hack project and not something that would be otherwise used. Yeah. Let's see, code. We were back on code. Here. Okay, so this is some debugging. So one thing that I pointed out to Ben before we started is that I did switch away. I do kind of combine log debug and print Ks. And the reason I do that is that Golioth has default, we send the logging to our logging backend as well. So everything that you see normally on the Zephyr logging subsystem also goes back up. It gets compressed using CBOR. It gets sent over to CoApp. It gets sent back up to Golioth. And what happened was I was just sending back so much logging data that I was like, I just need to see this locally. So that's why some of the things are local with print Ks. Some of them are log debugs because those then have, those get sent back up to the cloud. So.
Yeah, actually, I'm wondering, and I'm sure people in the chat, I saw Fabio and maybe others. I wonder if one can customize the log levels per module per backend, and to be like, okay, when I debug
Yes, you can.
in my app, the console backend will actually output that, but the Golioth backend is not interested. I don't remember whether we have that level of configurability.
I'm pretty sure you can, but I actually on a per because I mean we define all this stuff up here, right? So log module
Yeah,
register.
and then it would be a matter of like when using serial backend and the app shell module.
Yeah.
What's the minimum? Yeah, I don't. Let's see if people can help us. But
Yeah, I
yeah, like
forgot how
that makes
many
sense. But
experts
you
would
wouldn't
actually
want
be
to
in the
not
chat too.
What's that?
Dangerous. I said I forgot how many experts would probably be in the chat as well.
Yeah, probably yes. And there's actually a few questions that lined up as well.
Okay, great.
And actually, maybe you want to take a quick pause here. Agustin is asking, are all these devices polling all the time?
No, not all the time. So basically, that is configurable at the SDK level. So that's in. Let's see if I set this up in the kconfig. It's definitely in the somewhere in there. I don't think I did it separately here, but we can set up. So if we went into like menu config, you could set up how often it checks in. If you wanted to really power conserve, you could set up PSM or EDRX, that sort of thing. And in the case of RPCs as well, we're working on some offline first versions of RPC as well, because right now it'll time out after 10 seconds because unless it gets cached at the tower, which I have seen in the past. But like if you're using a Wi-Fi device, it's just going to time out if you're asleep for 100 seconds. It's just going to miss that RPC, especially if you send a second one. Usually the first one I think sometimes gets cached somewhere in the pipes, but the internet pipes, the tubes,
Yeah.
Yeah. So other questions?
Nope, not at this time, I think.
Okay, great. So let's go back in here. So another thing that I turned on eventually, I had to turn this off first because I didn't know what I was really looking at, is that one thing that I'm very used to.
Oh yeah, I was going to ask you about how you deal with the colors and how you sort of encode them in the reply.
Yeah, so this is actually all coming through on the UART as well, where there's just characters that are there that make this work. So VT100 is like
whatever. No.
Yeah, exactly. There's like offset is like a caret, and then like an open square bracket, and then like a and then some
feels
code
really
that's there.
70s or whatever. But
exactly.
It's pretty cool. Like you can do quite a few things.
Right. And so at first I had that all off because I was just like, this is too much for me. But then this is actually where it gets defined. And so this is actually the init function. So you get some flags, you're turning on whether or not you're turning on the colors of VT100, and then calling the shell init. That's the function we already saw out there. Ultimately, when these are on, if you just looked at the raw output, actually we can see the raw output. What am I saying? Let's try that here. Because when we look at the RPC, you actually get to see the response here too. So let's just do, let's do I2C scan, I2C at, this is gonna probably overdo it a little bit. Oops, this is the wrong method. This goes here, that's parameter. And then this one is remote shell. I think this one has formatting. Okay, so that shows that it went okay, right? And then this is the thing that went through, and here's the response, right? And so now we have, so then you start seeing like, line endings.
Okay, but then I guess those color code.
Yeah, this one doesn't have color codes.
Colors, I guess, right?
This doesn't have color codes, yeah. So where's a good example of this? Let's just try help. Help's a pretty beefy one. This definitely has some bump ins here. So like, oh, actually, this is not. There it is. There's one. Here we go. Yeah. So you see like those kind of escape characters and then things like that. And then that ultimately is what looks like here as well, right? So what those are doing are things like indents and things like that. Yeah. So those are all getting sent back. Those are actually raw characters that are getting sent back through that RPC. And then I just put it into the front end processing of it. I assign colors, it's like this sort of thing. I guess I probably have that one there as well. If you just look at high, Did that one actually come back? Oh, interesting. So this one did get sent all the way down through. Oh, that's why. So this is not an RPC, right?
You look
but
for
if I do,
remote shell.
yeah, thank you. There we go. So if I do that, that's why. Okay, so now we look at this return. Now we see things like colors as well. Yeah. So pretty interesting. Like just stuff I never knew was under the hood, but it's there.
Yeah, and then you have like whatever JavaScript library to display and see colors and translate that to HTML.
Yes. And I should be completely upfront. That was not me. That was an LLM helping.
Yeah, I was going to ask, but I knew the answer. Like one can tell.
You could just tell. Here's how you can
like,
tell. Right up here, netlify.app. That if you see that anywhere these days, it's probably.
Yeah, but I mean, it's awesome. Like it looks super sleek, and why would you? Yeah, I mean,
well, I don't really have any use case. So like basically, Goliath has really great front end engineers as well. Like this is not important enough for their time for a hack project. This is the place
it's just
to use
plumbing.
it, right?
Like it's just
yeah, exactly. So and also to lean in. So like JavaScript is something that a lot of LLMs are great at because there's so much example code out there. Zephyr, not so much. It's like, hey, I index Zephyr to 2.7. Would you like me to write this code for you?
So you didn't try at all to get some help for like writing the shell backend, or did you? And then it was just crap.
I tried it. It was a mess. It was not worth it. Yeah. So
interesting. Okay.
All right. And anything else in here that you wanted to see with the code? Let's see this.
Yeah, and I guess one thing. Did we say that? We kind of said that in the intro. You can have multiple shell backends active at the same time, right? Like it's not because you're enabling this one remote shell that it prevents you from using the good old serial shell locally.
That's right. Yeah. I learned this actually the hard way, where when I was building this device on my bench here, so I had basically used the shell. Our standard method is provisioning. If you're going to use pre-shared keys, which is like symmetric keys, which is not production ready, but for prototyping, you push them in over the UART using the serial shell. And so I did that for this device. And then I, kept reprogramming it, trying all these different things. And it was still had the right credentials in Flash through reboots, and it connected to Goliath. And I was like, great. And then I tried programming that same image now over to a new device that doesn't have credentials in there. I'm like, how do I don't know how to get the credentials in there because it didn't have credentials, so it couldn't get to the cloud to get the shell, that sort of thing. And I had thought that you couldn't connect two shells at the same time because there were some conflicts during development. But then I just turned it back on, and it came up. And you actually do see it's actually not on this device yet. I forgot to program that newer image on this device, but so I just call it like local shell and remote shell, so that you can see, there's a little prompt that you see, that sort of thing. It does work with both. And because I have that print K logging, then you actually see, if someone has a remote shell connection to it, it does output it to the UART using print K. So you do see that there's a new command that came in, you see the output, that sort of thing. So you do actually see all these commands as they come in, which we can see here. Yeah, so we see that this is actually the output here. So you see like this is the formatted version of that I2C scan, right? So
a quick digression, and I will turn back the question to you, George, asking like, or commenting on the fact that it would be helpful if Zephyr added a RAG enabled to the documentation. We have a PDF already. Do LLMs need more than that? I don't know. Should be already good enough to point your whatever your editor of choice to. You can also, and I think Jonathan is mentioning cursor in the chat. You can point cursor to docs.zephyrproject.org, and it would basically index it and refer to it when it needs to. Jonathan, reading the question out loud here. I've had some success writing C Zephyr code with cursor, and better than nothing with context 7, which actually I never heard that name before. Interesting. I'll have to look it up, but not quite there yet to write a real application. Yeah, I tend to agree. It depends. Like usually what for me personally, where I've had really good success is when you take the time to sort of manually instruct the LLM, and especially when you use something like cursor, you point it to an existing piece of code that already does that you know should be used as a starting point, like an existing code sample, potentially an existing test case, and then like make sure that it knows that it should be working off of that. I don't know if you guys remember, but a while back, I mean a few months back, when Zephyr shipped support for USB MIDI, whatever demo I put out there with effectively a MIDI enabled device that would do like all sorts of crazy stuff, including a really nice GUI and controlling the backlight on the keyboard using the Zephyr LED strip API and LED RGB, blah, blah, blah. All of that was like, or 99% of that was LLM. And it was pretty impressive because it was actually using a brand new subsystem, which by definition the LLM had never seen before. But like I just said before, by pointing it to the existing code sample that was just brand new as well, but by putting that as part of the context, then it was able to basically adapt the code sample to make it do whatever I wanted to. So
That's pretty cool.
Yeah, that was the long digression, but yeah, I use it a lot myself to do exactly like you, Chris, demos. Preparing, like I said, Zephyr 4.2 demos. We just added support for MQTT5. MQTT has been around for quite a long time, so when you want to build some kind of demo with a Python client, a JavaScript web page with like MQTT over WebSockets and whatnot, it just works. So that part of the demo, I don't want to write myself. I will spend more time on the Zephyr side probably, but yep.
Right.
So
And
yeah,
I mean, it sounds like the same way that when I'm stuck and I'm like, I don't know where to go, I go to docs often, but much more useful to me is finding someone's GitHub repo that's at the version I'm at. Like if I could find that, man, that's going to be, I'm going to crawl that with my eyes even before I put it into an LLM, right?
Right. Yeah. Yeah, let's see. I'm gonna just briefly put my screen on. George is asking, maybe it's too well hidden, but it's right there. If people want to sort of like peruse the PDF documentation, which I should remove the question so that it actually shows. There's a link right here, and there's like a 20 megs or however, maybe not that large, but it's a few thousand pages.
Small enough to fit on your Kindle for your beach vacation. Right?
Yeah, well, but actually, I mean, when you're on the plane or whatever, it's
That's
nothing
yeah,
that
actually,
you wouldn't find in the Zephyr code, because like if you browse the doc folder in the Zephyr source tree, you would find this documentation. But still, it can be useful. It looks pretty nice. It's yeah, not sure that I would be reading that at bedtime. It's like boring.
Make you fall asleep quick.
Book,
Who knows?
but
Depends on your style, right?
Right. But I think feeding that into whatever LLM should probably bring some reasonably useful results. Otherwise, like I said, cursor, you can just point it to the to docs.zephyrproject.org, and it just crawls the website and indexes it and does whatever behind the scenes so that it can refer to it later. And of course, it knows about your local workspace as well, where you also have the sources. So yeah, enough with digressing. Let's see, putting your screen back, catching up on some of the questions or comments, Louis. Of course, BLE shell is pretty awesome.
Yes, it's great. I'll be using that a lot for our new Bluetooth stuff. Some things that were new for me, I had never really created a custom command before.
Yeah,
so that was surprisingly easy, which was very nice. And And
Yeah, maybe show
yeah,
the. Can you show the macro first? Maybe the macro that sort of declares CMD list. You probably have that. Maybe. Oh, there you are. Lines.
so this
Yeah.
is just down here. This is just a single, so there's not like
Right.
the
But this is where
multiple.
potentially, if the command would take arguments, you would sort of indicate how
That's right.
many required, how many optional.
That's
You
right.
would maybe
Yeah.
put the command underneath, like a command hierarchy. Yeah.
Actually, I
Yeah,
do
yeah.
that
I
here.
wish we would have. We already have quite a lot, but I'm sure we have a few modules here and there that could use a shell interface. I was speaking of MQTT. I would love for someone to write an MQTT shell, which we don't have. Would be pretty
Oh,
cool
really?
to
Oh,
just
interesting.
like Mosquito Pub, Mosquito Sub on your desktop, having the same CLI
Yeah,
kind of experience on the device. I think would be nice. And
that'd be
tip,
nice.
like hint,
Yeah,
pretty
nerd
sure this
snipe
is something
incoming.
an LLM would be really happy to help write. So if someone feels like contributing an MQTT shell, I think that it would be reasonably easy to do.
Yeah. Okay. So this is actually a different one that I created. So this is closer to that. I think this is what you were talking about, the subcommand create.
Yeah.
And so this one has multiple commands that I set up here. And this is actually to control a screen that I was furiously trying to find and plug in while Ben was talking about cursor. But that's here. Is that backwards for you? Oh boy.
It is,
Right.
but
Well,
cloud.
that's subpar. Photo booth. Yeah. Let's see if I can switch it up. Yeah. I don't know how to do this. Can I flip it? I don't know how to do that. So,
It's interesting because it's almost a palindrome. Like it's Pem Buell, whatever.
yeah. Well, I guess I'll show it. Man, that's
So
stinks.
one thing that Fabio is asking, and I don't know if you tried, and maybe you can try. I'm not sure how you would actually send if your
Good question.
content allows to send that, but typically the Zephyr shell has really good tab completion, and you want to sort of like autocomplete a command name or even the command arguments. That should
No,
work, right?
the answer is no.
Why not? Because you
I
use
thought about
the
it, how I would send it back through. I didn't have time for that. So
right, yeah, and I guess you always send like full commands. You effectively, whenever someone sends the RPC, you add \r/n, and it's effectively like
yeah,
you type enter, I guess. So tab wouldn't
right. Yeah, on an enter, that's what does it. So if I do something, so I mean, tab will not work here. There's no
Yeah.
tab response sort of thing. But if I just do a partial, so like that I2C scan that I did, oh, that's a bad command. Never mind.
Let's wait 5 seconds for it to come. Oh, 2 seconds. That was
2 seconds. Yeah. That's the cell towers, just so we're clear. So this is actually just returning all of the things. I even got that one wrong, right? So this is just saying here's all
that's the way it works.
I2C.
When the command doesn't exist, it typically does that. Yeah.
Right. And same thing if I actually type it in correctly, it'll tell me now the devices that are here. So this is kind of this is my effective.
Yeah, that's the old school tab.
Yeah, right, exactly. The guess and check. And this is that same one that I sent on the command before, or on the. So there's that.
Yeah, that's
and
pretty cool.
Yeah, if I added other click headers. So this is actually on, although it is backwards, on this side or here. These are click headers here, which have thumb. And so I could put in other I2C devices. Obviously, this is quick. So this is also I2C. So you could see as we have more devices here. Yeah. And so this is the custom command that I put in. So I put in Ostentus, which is the name of that display. Here's the reasons I had this sort of thing. So Ostentus update text. Hi, Ben. I think it will render. I think that'll work. Ooh, extra slow. But yeah, there we go. Hi, Ben. Yeah, just believe me. If it flip it around in your mind,
I think there's Unicode characters that are sort of backwards, but I guess that wouldn't work. You know what I mean? Like we could actually send like like Unicode characters that are effectively mirrored, but then I guess your display
Oh,
couldn't see
jeez.
them.
Yeah, I don't think I'm processing those properly on
Yeah.
the Acentus, because that's another subsystem where this is actually running an uh, RP2040 on the back here, and then
Mm-hmm.
that's controlling the e-paper, and then the whole thing talks using a custom library over I2C. So probably not rendering it there as expected.
Yep. And so
So it's just
what are like your favorite shell commands, the ones that you always sort of like end up using?
yeah, I think sensor get. I think that's probably one of my favorites to show.
Sensor info, yeah.
Yeah. So sensor get lis2dh at 18.
And this is where
just
typically having tab completion is pretty handy, because you don't want to type the at blah blah blah.
I
But yeah,
I guess
yeah.
I get so much time in my life, Ben. I'm just very laid back and relaxed. But yeah, and then there is a replay I put in here too. Just simple, just replays the same thing. So
Oh, nice.
Taco cat. I like that. We could try that.
Yeah, that would have kind of worked.
Yeah. We'll see. Let's see. Taco cat. I think the C's are all going to be backwards.
Sure.
Yeah.
Yeah, ish.
Yeah.
Nice. Nice to see all the questions, by the way, folks. Feel free to send more. So was there anything else you wanted to sort of talk about?
I mean, this is all built on remote procedure calls. One of the things I wanted to call out that Ben and I talked about a little bit before the show, and he said he was going to take me to task for this sort of thing, is this is another thing we're doing. So basically layering an MCP now on top of RCPs as well, where you basically
way too many acronyms. Like, don't even assume people know what LLMs are. Well, I mean,
good point. I think yes,
most people do, but please take a moment to.
Sure. So we were talking about coding infrastructure using LLMs, which is large language models like Cursor and OpenAI or ChatGPT rather, and Claude, and the various models that are out there. Those are basically chat engines that'll help you write code. Well, then if you wanted to reach out to other programs, you might do that using something called Model Context Protocol, MCP. And that's basically this very, very simplistic interface that basically talks over HTTP, and it says, hey, what tools do you have available for me? It sends back, hey, I've got these various tools.
Yeah, and I'll keep that in mind if you ask me something that I feel this is the right tool to use for. I will be interacting with the tool, sort of thing, right?
Yeah, and so then Dan, who's also in the chat here, so Dan wrote basically a MCP agent that you can run on your. Sorry, agent's a bad term these days, way overloaded. It's basically an MCP program that you can run locally on your computer that then talks to the Golioth backend, like we're showing here as well, using REST API, talking to remote procedure calls, and then using another thing that we have called LightDB state rather, that lets you say, here's what my device can do. So in this, in the example use case, actually I have that device here. So if I switch devices, it's actually this device. So in this device, all I had was light on and light off, right? And so these are RCP, these are remote procedure calls that just turn on an LED, turn off an LED, right? Very, very, the simplest example possible. And this MCP tools and schema basically tells this Go program that's running on your local machine, hey, here's what I have available. Then you expose the Go machine to your large language model. So if I'm, for instance, say I'm running Cursor and I enable MCP locally, right? I basically point Cursor at the MCP and I say, hey, if you wanted to turn on a light, you can go and turn on a light. And you don't even have to say, here's what the REST API is, anything like that. It's just here's the tools that are available. Go do whatever you think is
Do you
necessary.
even need to sort of mention anything like turning the light? Can't you just say, I have a
turn on the light
device? Yeah. Do you know what I mean? Like, because it would actually discover the fact that it can turn light on and off. You don't have to.
Right. Yeah. I mean, like in the example video I posted, it was literally just, hey, turn off the light. Hey, turn on the light. That sort of thing. It's that level of language, which is very non-specific and not that useful in again, if you have a fleet of devices, it's probably going to return with, well, I see like 47 devices here. Which one do you want me to turn on or off? Right. that's where it might be problematic. But you might also have other tags in there that are accessible. Things like, this one is for, factory bay 25, right quadrant or something like that.
And so I need to play with that at some point. But if, like what we're looking at here, if this were to only say that there is a command to execute a shell command, and that's it, then I guess if you ask to turn on the light, the LLM would on its own figure out that, oh, there is a shell. Maybe I can try to call help and see what that gives me. And then it would figure out, like through a few round trips, eventually figure out, oh yeah, there is an I2C sensor or whatever, a GPIO that can flip. Like, would that work? Like,
I haven't tried that yet, but pairing those together would be very interesting. It would basically, expose the same kind of, you'd have to have generic, it would be less structured, right? You wouldn't have a schema there. You'd just have you'd have to have like kind of a text input, but yeah, it's possible. That would be, So and again, all of this stuff is being built on top of remote procedure calls. All of this stuff has existed since the beginning of Goliath, basically, because, this is a very inefficient way to turn on lights or to turn on, to check a sensor reading, right? You wouldn't want to do this across thousands of devices, but it's basically making it accessible at that level now. So that's interesting, kind of layers on layers on layers, right? That's, you've seen kind of all the turtles all the way down.
I mean, through the shell, you can expose things like battery life of the device and, I don't know, like available memory and signal strength of your cellular modem. Sure, there's many other ways to get those that are not through the shell. But yeah, like
what are your favorite shell commands? You had mentioned our shared love of the shell, but
anything network management is actually quite like anything you would do on your desktop, like ping and like looking at your if config and whatnot, like everything's there and feels very familiar when you want to do anything networking.
I find a lot of these aren't that. There's like sub things that I need to enable in kconfig that I usually don't have.
Yeah, because I mean, at the end of the day, it's up a bit of flash, a bit of RAM, so you don't always want all your commands to be there. But when you can afford it, that's well, put actually just put 888 or something, and it should work. Interesting.
That could be from this device. This is a cellular device.
Yeah, could be. But same as you, like sensor is pretty awesome. What else? Yeah, and also, like you demonstrated, if a command doesn't exist, it's usually not too hard to add one, like for whatever custom application you've built or custom driver. It can actually be quite handy to add the command as well.
Settings is another one that we use a lot at Goliath. This is how we set the PSK and PSK ID. So if I do settings, get Goliath PSK ID, you'll see the name of this device, which would be Elixir 1. This is really useful for me. I often name device. So this is device name at project name, and you see the remote shell matches the project name here. And so that's nice to be able to that's almost like a who am I. Another one I've talked about doing is pairing in our location service. So Goliath has a location service that lets you pull in things like cell tower or Wi-Fi access points. And then also there's GPS built into this specific one. So if you have like a cell, like this board has a cell modem and a Wi-Fi module using ESP AT, you can basically just do a lookup and calling it like, where am I? So getting a lat long back, that sort of thing. It's like pretty fun. So
yeah, it is. Yeah. Cool. So yeah, with that, let me see. Agustin, blah, blah, blah. Yeah, that was an exchange with Daniel. So lots of people apparently enjoyed the stream. We will be back next week before, I guess, taking some a short break during the summer. But next week is going to be all about just a few days ahead of the Zephyr 4.2 release, talking about video with Joshua, one of our co-maintainers for the video subsystem, talking about everything video in Zephyr, but specifically about real-time image processing on really small MCUs. Things
Nice.
like the kind of pre-processing or post-processing you want to do on raw camera images, typically like fish eye and like color correction and whatnot. It's been doing some really clever stuff, running just off a few kilobytes of RAM. So yeah, really looking forward to this one next week. So basically, as always, like it's kind of a feels like it's a ploy, but yeah, please subscribe to the YouTube channel and or LinkedIn to make sure you don't miss the memo. Anything else you wanted to share with us, Chris? I guess I should have put them on the screen, but even better if I put them in the comments. There's probably a few links worth sharing, blog posts and GitHub repos, etc. So I will put that in the YouTube and LinkedIn descriptions.
Great. Yeah. I didn't know if I could drop those in. Sometimes my coworkers who show up in the stream also drop them in, which is nice.
Yeah, I mean, if you put them in the private chat, I can put them on screen for a bit, but it might be even easier if we make them part of the description so that people can click.
Got it. Yep. Yeah, I mean, Golioth blog, we're always publishing about this stuff. Golioth console accounts are free for users, unlimited devices. This is the Netlify app. You'll only have this. This will only work if you have the shell sample, which is should be out shortly. So I'll be publishing about that being available to publicly. And it's basically just the code you saw.
It could also be a sort of a lightweight front end for anything RPC.
Yes, I mean there's RPC samples that are out there, and we have lots of published stuff about RPCs as well. But yeah, yes.
Right. Okay, cool. And we're pretty much right at the top of the hour. So I think we ran out of questions. People just check out the, as always, it's recorded if you joined late or if you if you're watching the recording, it was recorded, but check out the description for some of the links. And yeah, we will be back next week. Thanks, Chris.
Great. Thanks for having me, Ben. I appreciate it.
Bye.